Hi guys, so we're going to do a repair today. Well, technically the last video, but one was a repair, but it didn't really end right well. Hopefully this one will be better. So this is a MacAllister charger. I believe this is B&Q's own brand. For those of you in the States, I think Home Depot, as far as I'm concerned, they're more or less the same thing. B&Q's stock isn't as good. But this was apparently absolutely fine and then wasn't. It hadn't been used for a while and it now doesn't work. So this could be a really quick video. Let's just plug this in, turn it on. And indeed we're doing nothing. So I've done no checks on this at all. No nothing. So I suppose the first thing we need to do is see what state the fuse is in. So what I'm going to do is set my probes on resistance and go across the live and neutral. What I'm seeing there is about 1 megohm, so there is continuity there. We'll pop that fuse out of the plug anyway, sorry, off camera, and we'll check it. 3-amp fuse, it's what should be in there. And that's fine. And we've got, as I say, continuity there, but it's in the megohm range, so not necessarily what I'd expect to see. So I guess what we need to do now is take this apart. I think this has been used about 3 times, but oh, it slides out. It's been used about 3 times, but it's for a strimmer, I believe, so doesn't necessarily get used that much. Let's have a look at the battery. So I'm happy with the battery. So, right, how do we get into this? 1, 2 screws there. I had screwdrivers a minute ago. I'm guessing there will be another underneath. Let's pop that out of the way for now. There'll be more under there. I'll put money on it. This hasn't been abused. It has stayed completely indoors. It's not really been exposed to damp. Will that come off like that? No, there are more screws under here, aren't there? So there's no reason that it should have spontaneously died. Oh, these are actually little pop-in feet, so they can go back on. But who knows? A lot of these things are built down to a price, especially the O-brand stuff. This is a UK piece of equipment, which means we shouldn't be quite so heavy on cut corners in here. And we are in. Is there a way? Yes, there is. So, can't really show you that well in here, but we've got, if you look down in here, you'll see our connections are Celastic. They're Celastic to themselves, so the Celastic is doing absolutely nothing. So what we've got there, a couple of LEDs and the charge connector. Those wires aren't that good. There is indeed Celastic everywhere. Now we were getting a continuity reading, so my guess is that fuse is going to be good. 1, 2, 3. Yeah, no prizes there. We do have a fair amount of Celastic all over the place, and we do have some input protection. So it's generally all of this input protection and filtering that your Chinese stuff tends to be missing. Just don't bother with it. And looking at what we've got here, so we've got all our filtering, we've got a bridge rectifier, our reservoir cap, a chopper transistor there. My guess is there is going to be a single chip on the back of this. Is that everything out? It is indeed. I think I can bring you down. Whee! And there we are. So there is a single 8-pin device there. HAN02. And as far as I can see, we are good most of the way there. What I'm going to quickly do is, because we know all this is intact but this probably isn't running, is just check this cap. So there's 8 volts there, so we'll just kill that. So the problem with this is there's probably really not going to be a lot we can actually check. The usual thing to go for is the bootstrap capacitor there. We'll turn the soldering iron on and we'll pull that out and just check that. I am not seeing any bulged caps, I'm not seeing any burnt caps. There's no fuse gone, so that would imply that whatever happened wasn't catastrophic. So, as I say, we'll check that bootstrap cap just because. We can probably check that reservoir cap, but I don't know that that would tell us much. Again, in circuit, so all bets are off. We're looking for 1,000 microfarad, 100 microfarads, and we're getting 98. And that's perfectly acceptable. This isn't that old. Is there a date code anywhere? MHC caps. I have heard of those before. That's an FCI chip. FHF8N60. I believe that's a MOSFET. Soldering doesn't look especially good. Right, our soldering iron should now be warm. And where's our bootstrap cap? So 22 microfarads, 50 volts. Drink. Bang on. Didn't think it would be that somehow, but it always pays to check. And now we've got to get it back in. Right. So that's that bypass cap back in, and we know that it's not that. So, what I'm going to do is we're just quickly going to pop this LED board out of here so I can get some feedback as to what's going on. This is not going to be as easy as it appears. What we've actually done is threaded that LED under the battery terminals. Can we get that out without destroying everything? My guess would be no. Why would you do that? I think, nudged it. I do think we've got to take the whole thing apart just to get the LEDs out. Seriously, all I want is the LEDs. That's not too much to ask, is it? How in... What's the point? How have I gotten 3 of the 4 wires out? Or 2 of the 4 wires out and not the other? Well, there we go. And breathe. Right, as you can see, this elastic does absolutely nothing. Right. Live electronics. Fingers away. A cup of tea should probably be away as well. Right, we are on VLOTs. And we want to start on VLOTs AC. And turn it off a sec. Large defib cap. What I actually want to do is see what we've got going on the bridge rectifier. 230 volts AC. .300 volts DC. 300 volts DC there. So as far as I can see, we've got kind of what we're expecting there. Let's turn this off again. How quickly does that cap discharge? Not as fast as I'd like. We will avoid touching that side. So somewhere here there is an enormous diode, which will most likely be this here. That is a Q. There's a reservoir cap here, so we want to check these two reservoir caps and see if there is any voltage there that could indicate that our power supply is running. So we want there and there. There's our diode, there and there. Right, power on again. So that's run reservoir cap. As you can see, there is nothing there. And the other one was down here. There is nothing there. If we check our diode, let's pick a ground. That looks like it's probably a good ground. We have nothing which suggests that our power supply isn't even running. Let's have a look across that bootstrap cap. Also nothing. We are on, aren't we? Yep. Okay, right, what we need to do now is go and look up this chip if we can, and look at the suggested circuit for it, and hopefully get an idea of what's going on. It should be a fairly off-the-shelf chip, so we shouldn't have any problems finding a data sheet. So off we go. Right, back and we have a data sheet. Surprisingly dark over here. What have I done wrong? No. Oh, I know. Actually, with the white data sheets, it's probably not a good idea. So we have the data sheet, and compared to the general cheap Chinese power supplies, this is quite a flexible and well put together chip. So that's what we want there. That probably bears more than a passing resemblance to our power supply. I will link the data sheet down if you'd like to have a look. There's the circuit, and that looks like very roughly what we've actually got here. Before I grab that, make sure it's turned off. So we've got a couple of places we need to look. So the first thing is we've got pin 8 and pin 1, RT and HV, and do we get pinout descriptions? HV is fairly obvious what it is. There we go. RT connects a switching resistor to ground. This resistor determine the switching frequency. Okay, there's Chinglish in here. So pin 4 is our actual ground, so we want to be, let's just have a look. So I don't believe that's pin 1. That is pin 1. So we want to look at pin 1 off of this resistor. We should have 2 resistors, and now across the bootstrap cap as well, and there's a diode there, so that will be this assemblage up here. They've used 1 resistor. Let's have a quick poke, so to speak. So we want 4 and 1, so that's 4, which is ground, which I'm not overly confident, I believe, and that should be our high voltage. I can't actually see my own meter. We are definitely on. let's go on to pin 4. So we have no high voltage there. Apparently that should be straight off the rectifier. No, I'm reading it wrong. It's actually pin 8 and ground we want. So there's our ground, there's pin 8, there's 300 volts. So we've got our high voltage. The next thing we need to do is look at pin 6, which is our VCC. We decided that our ground was there. 9 volts, does that sound right? Bear with me. Now we're saying that our supply voltage should be 35 volts, so that's definitely that pin there, and that's definitely our ground. 9 volts, is that acceptable? I suspect not. So why, turn this off, yes I know my cap's under there, why would our VCC be low? So there's our C7, we know that that's good, we've checked that. So we're going through 1 resistor and 2 J's. What are the J's? We do actually have a parts list here as well, which is really good. J's are 0 ohm links, so R6. Where are we? Where are you, R6? R6 should also be 0 ohms. 0, 0, 0. CR2. So we've got these here on a feedback winding. I think I can see that on the board. It's difficult to get this so you can actually see everything. So my guess is this is our feedback winding. We've got a component there which is a diode. So let's just poke around that diode. My screen on this is actually so scratched I find it quite difficult to see with the light on it. So diode that way. Nothing. Diode that way, and we've got diode drop, so that's fine. So that diode then feeds that cap. Now I'm sure we said that there was nothing across that cap. Let's check that again. Because we've got to be getting 9 volts from somewhere. So that's our ground, and that's the output of the diode, and that's 16 millivolts. That seems not right. Let's just go on hertz. So that's just picking up mains hum. So there's nothing coming out of that feedback winding. How would that work? We are on DC, aren't we? Yep, let's just quickly check again. Lots of lots. So, oh, it's in that half. Didn't realise that. That's horrible. We've got nothing going on down there. I wonder, could that Zener? We know that that cap is most likely okay. Could that Zener be shorted? Oh, we've also checked that one. So that Zener is worth checking, assuming there is one. We've got VCC on that pin, so that means something must be happening. I'm not even seeing a Zener. Could it be that diode there? D5? D5 is actually on this side of things. So what we've got going on here, everything's wrapped around everything else, is we've got our low voltage side here and our high voltage there. So there should be a Zener diode somewhere. DZ1, there it is. But that is involved in the feedback circuit. It could be the Zener. Go back onto diode drop. That doesn't look great. That really doesn't look right. I have no idea what voltage that Zener is going to be. What's across it? Cap and the coil. So we've got, I don't want to zoom you in too much. So we've got 3 pin there, we've got a transistor there. I would say that Zener is more to do with the feedback side of things, but do we have a feedback pin? 2, comp. That goes up there to that resistor. Voltage feedback. 1, 2. That's being... actually, it doesn't look like it's this ever been used at all. Oh, we've got another diode up there, and that's... what? What's pin 6 is VCC. So what is this optocoupler actually controlling? Looking at that Zener, it does look a bit baked. Let's see if we can get that off and check it. Where's the end of me meter, which I've now put down on top of it. So my Zener is off. So we're on diode. That looks about right. Not sure about that. That doesn't seem awfully diode-like. Let's just go back onto normal resistance. 315. That looks more like a resistor than a diode to me. Now, we have no idea what that Zener should be. Let's have a look at this again. So I believe we are looking at ZD1 there. Does it give us a value for it? I'm sure that says ZD. Where are we? We're on the back of this. ZD1. I can't see it. ZD1 NA. Okay, that's useful. Now, the question is, we don't necessarily know what that Zener diode was doing, and it certainly doesn't appear to have any identification on it. Yeah, I didn't think that would help us. 315. So I think this is our problem, but I don't know what it should be. So it's definitely involved in generating our VCC. What do? Do we start with a low value one and see where that gets us? Bear with me. So, back again with my bag of Zeners. Trying to think where we start. 18 volts looks to be... There's a 30 volt one there, but I think 30 volts feels too high. We can certainly try it, I guess. No, let's start low. Let's go for 13. And what we'll do is, just to make sure that I'm not being an idiot, we'll just meter these out as well. And on diode. There we go, we're on diode now. One that way, one that way. No, so they should read as normal diodes. I thought they should. Right, we've got a black band on the PCB which appears to indicate where our arrow should be. So we'll wet the end of that with some solder. I will go and get some other solder in a minute because this is just unusable. Come here. Where's our leg? There. I'm not convinced this is going to help us. And we're soldering onto SMD pads, so we've got to be careful not to apply too much mechanical stress to anything. Right. Will it go bang, or will we get a power light? Oh, we have something. Don't know if you can see that. Battery on the camera is getting critically low, so let's really just quickly meter out a few things and see what's going on now. We've got 20 volts across that capacitor. Where is the other one? I think it's there. 20 volts there. Nothing feels to be getting upset. Let's kill the power on that. Our battery voltage is 18, so 20 could be about right. Hopefully that will stand up there without too many problems. Put all our screws here. Is this long enough to reach? It might just. Oh, this is all getting very, very Heath Robinson here. That was that diode bending. Don't want that happening. Let's just rest that on something conductive. What I want to see is some signs that this is doing what it's supposed to do. Bang! We're charging. Right. Battery in the camera is about to go, so I'm going to turn you off. I'm going to neaten up that diode and find a way of doing it where it can stay on the board okay. And then we'll come back and maybe we'll let this have a run and see what happens. So, back soon. Right, back again. Battery's charged. This is sorted. I have made a slightly better job by just zooming you down on that Xena, if it'll focus. So I've gone between the pin of the transistor next to it and the original pad, just to make life a bit easier for us. So what we need to do now is put this back together. It has run for 10 minutes charging. So let's pop this all back together. Let's get rid of all our paperwork. And then we'll put it on charge for a while. And make sure all is good. I know what voltage I'm expecting at the battery at the end of charge. So we should be okay. We'll take that out again. Right, that needs to be around that way because we've got a cable gland there. Incidentally, if you look closely, you can see where that LED board came from. Now this should sit back in here fairly well. There we go. We are sat where the screw holes say we should do. Pop our cord grip back in. And then our two screws down here. So I've been involved in electronics for quite some time, and there are two things that I have generally avoided where I can. One is switch mode power supplies, and the other being lithium batteries. Lithium batteries, still not feel happy about them, but switching power supplies now I'm fairly comfortable around. And I have to say a lot of that comes from watching Dave at EEV Blog, Big Clive and similar, and realising that contrary to the high magic that I was always led to believe was deployed in switching power supplies, and the fact that they have become a hell of a lot simpler, they're not actually much to worry about, and there is only so much they can go wrong. You're generally looking at a single component failure or a complete power supply meltdown, the technical term for which is catastrophic deconstruction. However, I cut my teeth on linear supplies. I understand how linear supplies work. I understand how to design them, mostly because of a lot of what I did when I started was high-end audio or instrumentation. Both of which had very, very strict requirements in terms of... Which way does that go? Very, very strict requirements in terms of how their power supply should be. And it wasn't something that switch modes at the time could easily reach. It wasn't unusual for us to use a huge Cootant power supply in there. Or even on some of the systems a smaller TDK, or even... here's one for the past, a Vero power supply, and then we'd back that up with a linear supply to provide the supply for all the data acquisition equipment. Not the case. Modern switch modes are simpler, more highly integrated and more reliable, so really there's not much to be afraid of. You need to remember that there is mains. Not so much with Big Clive, but when you're watching some of the American YouTubers working on this equipment, you need to remember that our mains voltage and the Australian mains voltages, indeed most of the European mains voltages, are quite a bit higher. You need to be a little bit more careful. 110 volts is ouch. It can kill you if you get it wrong. But mains in the UK and Europe can actually do you a fair amount of damage. Certainly you're into the point where you can kill yourself on mains over here, and accordingly your reservoir caps in switch modes can be at substantially higher voltages. You saw that one at 320 volts, but there's nothing really scary in here if you know your way around electronics and electronic components. They are eminently fixable. Again, an advantage over when I started is the fact that datasheets are free and easy to find as a rule for most of these chips. And although that circuit we had there wasn't oops, wasn't the right circuit for the power supply, it did tell us where to look. Now I've put the back ones in so we'll hold that better. No, I've put the front ones in. Who cares? Right, turn it on. We have a power light. Doesn't seem overly dim or anything. That to me feels like that should be the front there. But that's upside down. Oh well, never mind. Battery goes on there. And there you go. We've got a flashing light indicating that it's charging. So, yeah. What I'm saying is don't be scared, be careful. But these things aren't that difficult to deal with now. And certainly they're not the black magic they used to be. Anyway, I'm now going to leave that charging. I'm going to wait for that to terminate the charge. And once it terminates the charge, I will check the battery voltage. But I think we're done here. So thanks for watching. And I will go and find something else to drag onto the bench for the next video. Take care.